Hello and welcome to Generation AI, the podcast where we demystify artificial intelligence in the world of higher education. I'm your host, Ardis Kadiu, joined by my insightful co-host, Dr. JC Bonilla. Hey, JC, how's it going today? Lots of news for us to catch up on.
Ardis, I'm exhausted from catching up from the AI news. Seriously, my gosh, I cannot keep up with this thing. It's amazing. But this one, this is a big one. Probably I'm going to say then the same thing about the next one, but it feels a big one. I was so excited. To see some of these features and new product drops. What do you want to lead with for the bonus episode?
So we had two really big news happening last week. One of them was Gemini 1.5 that was introduced by Google. This was really big news in itself. And then 2 hours later, guess what? OpenAI steals the thunder, releasing their model called SORA, which is a video model. Now, both of these would have been news within itself, but put it together, and now you have a really, really big week in AI. So we're going to unpack both of these releases and what they mean, what are the actual products, and what are the ramifications for AI, and how should we be thinking about it every day.
Ardis, these two alone, actually each of them alone, represent technological shifts that are disruptive in nature. They just happen to be casually dropped, a week, a month after, like a week within each other, days within each other, right? Hours within each other.
Hours within each other.
Months or weeks within the rebranding of Google's Gemini is just unbelievable. The time compression and development and acceleration of features and advancement, it's unprecedented.
So Google announced Gemini 1.5 Pro, which is an update to its large language model and now offers a lot of really great improvements over its predecessor, which was Gemini 1.5. So it's really designed for understanding reasoning capabilities. And one of the big things, it supports up to 1 million tokens. So let's unpack that a little bit, right? We're going to talk a little bit about kind of what the architecture is and the efficiency, what that means, because it's something that it's really, really important when you think about it. We're going to talk a little bit about the context window of the capacity and the performance capabilities. So let's start with the architecture and the efficiency. Essentially, what Google has been able to do with Gemini 1.5 is that they're employing a state-of-the-art where they're calling a mixture of experts. This is really interesting and really good because what it means is that it can actually use different parts of the network, the large network, in order to turn certain features on and off. So because it's a multimodal model, it's able to understand that if the input is a text input or if it's a video input or if it needs to work on audio, it will turn off certain branches of the network to make it more efficient and a lot faster, which is amazing. It's lower energy consumption and it's able to do these things a lot faster. So huge, huge capabilities there.
Ardis, an expert, right? Network of experts. So the layman's man approach here is I have an expert that does my taxes. I have an expert that does my plumbing. How do you take this in the context of AI? Is an expert, are you saying that they're talking to all the plumbers, or we're talking about at the object level, at the graphical, if I want this, is that what an expert is? Can you contextualize what an expert is in AI here?
Yeah, so traditionally, large language models, you're adding more and more capability to it by billions and billions of neurons or billions of variables that you're adding to these networks. However, the larger these models get, the more energy consumption they have. So the more memory you have to fit them in memory and the more you have to run them in order to produce something out of them. What we're trying to do here is trying to identify as these networks get really large and these large language models get really large, they're going to become multimodal, and that's what Gemini is. But in order to be very efficient, you want it to be acting as a small language model. You want it to be acting very, very fast. So in order to do that, you can't load in all of the model in memory and expect it to work. You need to shut down certain parts of it. And what that is, it's certain experts. So essentially, it figures out what are the experts within groups of the large language model and turns those parts of the brain off. Think about our brain. Like we don't use all of our brain all at once. So if you think about it, it's the same thing here. If we get auditory input, certain areas get lit up. If we get visual input, certain areas get lit up. So it's the same ability here. These multimodal models are going to need to be efficient in order to produce things really, really fast. And that's how Google has figured that out.
That's incredible. So the analogy to the expert goes from accountants and plumbers to the idea that at the network level, they're experts. And knowing that not everything is needed at the same time is what gives us that energy efficiency. It's just impressive that we're at that stage today in 2024. What about this window capacity? What is that all about?
Right now, we know that we can only put certain amount of text in ChatGPT or Gemini. It only hold maybe what we call 32,000 tokens, or maybe a few thousand words in there. Tokens are almost close to the amount of words.
That's that for everyone listening. Can I translate that to the size of the prompt? So you're basically telling me now prompting became almost infinite? Is that what you're going to get into, or is it totally different?
Exactly. So the length of that prompt is going to it's really, really large. So now with Gemini 1.5, you can add up to 1 million tokens. So incredible. So now you can fit 700,000 words, 11 hours of audio, 1 hour of video, that because it's multimodal, you can kind of fit all of that. Code bases with over 30,000 lines of code, which is incredible, right? Because you no longer have to think about how much stuff you're putting in there. It's able to handle 11 hours of audio, then process all of that.
And the speed paralleling which is taking place is incredible. So in terms of the context window, we can just say it went from, being truncated to something to infinite, pretty much. Unbelievable.
Yeah, exactly. And of course, in research, that goes up to, in some cases, up to 10 million. And if you compare that to GPT-4, it's 10 times larger, 1 million to what GPT-4 has, which is 128,000 context window.
For everyone who cannot see this graphic that Ardis just showed me, we're looking at the LLMs and, from Gemini 1, GPT-4, and Claude. And you're looking at a scale that visually it looks like at least 8x, but what they're actually quantifying here is up to 10 million more in research.
So performance and capabilities have also improved, right? 1.5 Pro outperforms 1. Essentially, it's 87% of the benchmarks used by Google's LLMs. So it outperforms them on a lot of different areas. Things like in-context learning. It has better multimodal capabilities, so it's not limited to text. It can perform reasoning and problem-solving tasks across video and other visual inputs. So you can actually add video in there. One of the examples was really easy, where you can load a whole YouTube video in there and ask any questions about it without having a translation of that video, and it will actually kind of give you those answers. And it has really complex reasoning. So it can seamlessly analyze, classify, summarize large amounts of content within that given prompt, which makes it really, really easy to then understand and reason about complex topics in these different modes. We're now going into, if you think some of the other areas that has improvements or enhanced safety measures, it's, again, in both 1.0 and 1.5, they go a lot of checks to reduce potential harm and issues. However, the long context window in 1.5, there's some new concerns in there that Google now has to address those, and they have to conduct a lot of evaluations to ensure that there's some safety and responsible deployments with this really large context windows now. I'm not sure about the pricing, but Gemini 1.5 is available for private previews, so not everybody has access to it yet.
So it's more like an alpha beta release, right?
Correct.
Very, very exciting. And the interplay between performance and, I guess, cost of power, it's really interesting because you would expect this, to just basically need more to power. And it seems that that's the case. So good for them and good for us. All right, take us into SORA. How did OpenAI respond?
So basically, there was about 2 hours where Google was enjoying the news cycle, was dominating the news cycle. And then 2 hours later, OpenAI released SORA, which is a video model, a text-to-video model. And it really is amazing what SORA is and the examples that they put out. The first thing that they did is they put it on their website with about 24 or so videos that were generated from it. It became really, really clear. The graphics are amazing.
The graphics is like Pixar, Disney, like Hollywood movie production. Unbelievable.
Exactly.
Ardis, do you think they planned that? Was it just casualty? Like, how did you go from 2 hours from, Google versus OpenAI? You think that was just random, or more like this just happened. They probably have it for tomorrow and they just like go now. What do you think happens behind the scenes? You're a product guy. Also, you have comms team. How do you think that plays out?
I'm pretty sure they got some kind of a hint that Google was going to release that 1.5 and
Oh,
they're like, hey, let's just do it.
tech wars. Hey, remember the battle of the LLMs? My favorite episode that we've done so far.
We still have to see what happens on that one. You won a couple of battles recently, but OpenAI is certainly winning the news cycle.
I was going to say, I know this is just an update. We're not taking bets, but on this tech drop, OpenAI kicked butt. Literally much better impact. Just measured from PR and perceived technical capabilities, OpenAI blew my mind. Blew my mind.
Again, we want to simplify it a little bit and kind of talk about what SORA is. So SORA is essentially a generation of video from text prompts. So you provide a prompt very similar to an image or Midjourney that's generating images. We had Runway or Pika.ai, which were two of the video generations. But until now, we were limited to just a few seconds of video, and the video wasn't very good, right? It was not so good.
It was not crisp. It just had all these components of, this is generated by a computer. It was literally, in video terms, like imagine a robot moving like 1980s, like that type of weird movement. That's what video was for these first two movies, right?
Yeah, exactly. And one of the things that SORA does, it comes to the forefront and it allows us to see up to 60 seconds of video generation with very, very realistic images and video. So, for those of us who are in the content production world, we see SORA and are saying, wow, what is going to happen to all of the TikTok streams? What is going to happen to all the Instagram and all the social streams now that you can produce all of this amazing content? The models are still battle testing, so they're still being red teamed. So these are not available for the public yet. However, a lot of the videos have made their way throughout the internet, and you probably have seen a lot of them. So let's dive a little bit deeper. What does that mean? How does this work? What is SORA exactly, the model? First of all, I love the name. They have done a really good job. They've been terrible with names before around GPT this and GPT 4, 3. A lot of people don't get it. SORA is actually a brand name, so they're treating it as a brand, which is amazing. So it's the first time that they're doing that. So I love the name. But let's dive a little bit deeper into what this is and why is it different. All right. So the first thing that we're going to talk about is how does it work, or exactly just explain a little bit about SORA. So it really generate realistic, imaginative videos from text instruction. It represents really a huge advancement in AI abilities, and it also understands and can simulate physical world in motion. So it essentially can represent physical objects, and it understands how they interact with each other. So SORA is a combination of what we call diffusion and transformer architectures. Of course, you don't need to understand that, but think about, the T in GPT stands for transformer. It's a transformer architecture. So think about how it produces the next word and the next word and the next word based on all of these tokens that it understands. With the diffusion model, that's how we were able to produce images so far. What that meant was that we produced a very blurry image and then slowly became into focus. And then you went to the next frame and you did exactly the same thing. So you needed a lot of memory in order to keep all these frames together. And that's why you weren't able to produce a lot of really long videos. Now they have taken both of these architectures and essentially put them together. So there is representations of video in the same way that they're representing text. So they're able to use the same large architectures of transformers in order to essentially treat pieces of these frames of video as text. And that's the kind of breakthrough, so to speak, from the research side. So now you no longer have to treat training video with just square images. So that brings out some really, really emergent behavior where, because it's using these transformer architectures, it's able to model the world and it's able to understand some intrinsic behavior of objects and video, of what that video represents, which is pretty amazing from a scientific perspective, what that represents. But also, the models have actually figured out how objects interact in the real world based on this representation of just little squares of pixels, so to speak.
So let's slow that down, because I think we need to just, give some explanation to what diffusion may look like. On text, right? An LLM, the transformer, what it does, it creates literally a map of all the connectivity, right, of the words. In a way, it's able to predict the next word because it's able to reproduce for this model, let's say Shakespeare, right, how words and how that, network of words take place, right? So it knows that when I have this word preceding, probably the best word to follow in a Shakespearean map does that. Take it to graphics. The part of frame by frame, can you just explain that to me? Because it really blew my mind to start thinking about if T for text, it's basically what's happening here, that network to prediction. How does diffusion work in graphics, right? And the computational power required for that is gigantic. So could you just slow that down for us, Ardis?
So it's really interesting. What they're doing is they are taking, for example, 100 frames of a video, and they're taking a square area of that particular frame of video, and they're taking 100 frames of that same kind of hole. So think about if you have 100 frames put together, and then you're punching a square hole through all of those frames. You're taking all of that data that's in those frames and you're putting it together into what token? They're not calling it a token. I think they're calling it a patch, I believe. But essentially, they're putting all of those together and they're using them the same way as they're using a token in a text model, right? So if they're using the same mechanism now in order to go backwards so they can predict the past, they can predict the future, and now they're getting all of those patches together in order to train the model. So they can throw an incredible amount of data now into that model, which can emerges all of these behaviors from it. So it's no longer, hey, I'm going to take this, single frame, but actually they're taking extrapolation of just a square over time, right?
So look, everybody, as we're trying to keep this up, I'm just going to give you a crazy analogy, right? What Ardis is taking us through is that for you to build that next architectural revelation of a building, new instruments, new engineering, new materials need to be deployed. And that's what just happened here. This type of patch, if that is actually the word, as an academic, I've never heard of that technique. So it probably comes from a research process, blah, blah, blah. Anyway, it's just an incredible technological achievement that requires the deployment of new techniques to achieve the very existence of what we're just discussing. So impressive, Ardis.
Exactly. So one of the things that's really important now, it's not just the ability to produce video or text to video. So you can provide a piece of text and it'll produce video, but some of the key capabilities are text to video, of course. It can generate videos up to a minute long, which maintains this really high quality and adherence to user's prompt. So it understands the user's prompt and it doesn't deviate from that. So it's really, really good about that. The other one is image to video conversion. So you can input an image and it can animate those still images, bringing them to life with accurate and detailed motion. Because remember that you can have different types of input on this particular architecture. It can do things like video extension and editing. So it can extend existing videos, or it can fill in missing frames. So it really offers kind of new possibilities for video editing and creation. Also some examples where you have a current video, but it can actually transform that video into different styles. For example, there's a car that's driving through a forest. It can transform that car. It can say car, driving in space, futuristic, or 8-bit video of the car. So it's transforming that car as it moves through that motion, which is amazing because now you can take essentially anything and transform into anything else, which is crazy.
It sounds that I've been trying to translate this diffusion aspect and how it takes place, but it sounds like what you have is this rendering of visuals as tracks, similar to how a music track would take place. So if I just want to come and change that violin out of the entire orchestra, I can actually isolate the frequency or the tracking we place and do that variation, remove it, omit it, elevate it a pitch, an octave, or whatever, or super overlay, a drum beat and things like that. Very interesting. And I did not see that application of how once you come in your prompt says, I don't know, give me some dinosaurs that are going over a forest with green flowers. When you get it, like, you know what, that green flower, the way it grew, I didn't like it. So you get to edit that just one bit and maybe see it frame by frame. That's fascinating, the application.
Exactly. It reminds me a lot of engineers or electrical engineers. Fourier transforms used to be, something that we did a lot. And it kind of fascinated me how you can extrapolate very complex waves from very simple waves. So it's very similar here in like I can use mathematics in order to represent, all of these different factors. But obviously we're not doing it. This is actually emergent behavior that's coming.
Fast Fourier transformation, artists. You just pulled that off here, by the way. Yeah, it's application of, sinusoids and cosines to decompose.
I'm not sure if that's applicable here, but it reminds me of that emergent behavior or of wave transformations.
By the way, big shout out to our friend Luc Dubois, one of the, pioneers on sound and tracks and music. He actually used the deployment of fast Fourier transformations to do one of his DJing applications. So look, check us out, my friend. Anyway, back to this, not NYU.
Exactly. So people are very excited about this. They're very excited about SORA. They're very excited about the opportunities that it brings. And they're very excited in terms of what SORA's ability to simulate virtual worlds or generate videos in any format. It can be very versatile and the potential is incredible here. Everybody's excited for the potential and it's going to revolutionize how content creation happens across a lot of industries. Art, filmmaking, education. Now imagine I can describe what I want an educational video to be about or B-roll for certain aspects and you kind of be able to generate that. So it's going to transform, like we can't get our hands on it just yet, but everybody who works with video in the video industry, they're producing a video for schools or they are producing content for social media. This is huge and disruptive. I mean, you guys are doing something very similar, JC, on your end, but I'm pretty sure this has not come up on the boardroom yet, or at least you guys are not freaking out yet.
Not yet, because one of the things that we specialize on is what is called contextual creative. The idea that when you do these videos, you deploy the features that the algo, the social media gives you. So the TikToks of the world, they need to come and catch up to this so that they know how to give you what is called organic ranking. And then your content has the potential to over-index or not. So it's the kind of thing that is too new, but I would say first order is the algos need to pay attention to it to see how they want to introduce it or not. And then advertisers will come and follow. Ardis, one question for you. Did you get to see the prompt? What is the structure of the prompt? There's the art of the prompt, if you will.
It's very simple. It's actually very similar to how DALL-E uses their prompting, which is very, very simplistic and it's very direct and very expressive. So, puppies playing in the snow, very simple, and then you get very incredible results out of it. So you don't need a lot.
Can I give you an SAT analogy here? DALL-E, it's to paintbrush, to SORA is to Adobe, right?
That's exactly it.
You get it?
Yep.
Right?
Such a leap forward.
And if you guys didn't get it, email us. We'll tell you what that means. But it's really, that's like comparative technologies, right? And then capabilities and incredible.
Exactly. So one last thing, obviously a lot of folks are really freaked out and, we're in an election year. There's a lot of folks who are on the other side of the line. We're really excited about it, but this is really the moment where it's, oh, wow, the quality of this video can be imperceptible from real video. And there's some ethical considerations here. And of course, OpenAI has taken some important safety steps. Before they make that widely available, they're actually going through and working through red teaming to assess the risks related with misinformation, hateful content, and bias. And they're also building tools to help detect misleading content. And they plan to introduce the C2PA metadata framework, the same one that Facebook and they're introducing in DALL-E as well. So basically, when you deploy this in the future, you're able to identify that metadata that this is a fake video or this is a synthetic media video.
Actually, I heard something different that they've all tuned up to our last episode on deepfakes, and they're applying the watermark concept that you proposed, Ardis. So that's actually the newest standard for handling this type of advancement on generative AI and graphics.
So you have to put it on real video, just like live.
Real video.
Yes.
There you go.
Well, this is a lot of fun. I'm glad that we were able to do this and bring you a little bit of an explanation of what this means and how this can be applied. None of these are available yet, so there's a lot of hype for it. So over the next few weeks and perhaps month, we're going to see some of the representations of these models in the wild or part of ChatGPT or even part of Gemini and Gemini.google.com as well for the 1.5. Hopefully you're just as excited as I am.
Ardis, I just want to say thank you for keeping us current, my friend. Thank you.
Generation AI is part of the Enrollify podcast network. If you like this podcast, chances are you're going to like other Enrollify shows too. Our podcast network is growing weekly, and we've got a wide range of marketing, enrollment, and higher ed technology shows that are jam-packed with stories, ideas, and frameworks, all designed to empower you to be a better higher ed professional. Our shows help higher ed leaders and professionals like you find their next big idea. They feature a selection of the industry's best as your hosts, like Jamie Hunt, Seth Odell, Jenny Lee Fowler, Brian Gross, and many of your favorite leaders in higher ed. Enrollify is made possible by Element 451, the next generation AI student engagement platform that's helping institutions all over the country create meaningful, personalized, and engaging connections with their prospects and students. Learn more at element451.com.